How many integers from 1 to 100 are divisible by 3 or 5? So let's count this carefully. So we can first start by how many integers are divisible by 3. So if you take 100 and you divide by 3, so 100 is going to be 33 times 3 plus 1, right? So 3 times 33 is 99. And so you have 33 numbers that are divisible by 3. So the numbers of divisible by 3 are 33 plus the amount that are divisible by 5. So of course 100 is equal to 20 times 5 plus 0, right? So there are 20 numbers that are divisible by 5. And so maybe one could think that the amount of multiples of 3 or 5 between 1 and 100 is just add up 33 and 20 and you get 53. But there is a problem here. And the problem is that some integers are divisible by both 3 and 5. So for example, 15 is divisible by both 3 and 5. And so when we are counting the amount of numbers that are divisible by 3, 15 is one of these. And 15 is also one of the ones that are counted as divisible by 20. So we're double counting. 15 is appearing twice. And so we need to subtract that. We also have other numbers like 30, 45, 60, 75, and 90, which are appearing in both. And indeed, what are the numbers that appear in both? It's exactly the multiples of 15. And so we need to subtract this. So we need to subtract the numbers that are divisible by 15. Because these are the numbers that are in the intersection, let's say, of divisible by 3 and divisible by 5, right? And so how many do we have? So 100, you can write it as 6 times 15 plus 10, right? So 6 times 15 is going to be 90, and then plus 10, 100. So you need to subtract these 6 numbers that appear repeatedly, and with this, you get our answer, which is 47. So there are 47 integers from 1 to 100 that are divisible by 3 or 5. And so this is the idea behind what's called inclusion-exclusion. And here we do it with 2 sets. So if the set A, so here let's relate it to what we were saying before. So if the set A is those divisible by 3, and the set B is those divisible by 5, then the set A intersection B is going to be the set of those that are divisible by 3 and 5, which we saw is just the ones divisible by 15. But the important point is that when you are counting the union of A and B, so when you're counting which of them are divisible by 3 or 5, so it's this union here, you are double counting the intersection. And so if you want to count the union, it's going to be the sum. So the union of 2 sets A and B is going to be the sum of the elements in A plus the sum of the elements in B minus the sum of the elements in the intersection. And so you can think of it as when you are counting, so let's say you have an element here, an element here, an element here. When you're counting the elements of A union B, when you count the elements of A, then this element here is counted only once. When you count the elements of B, this is counted only once. But when you count the elements of A, this is counted once, but then when you count the elements of B, this is counted twice. And so you need to subtract this to be able to get the elements of A union B. And so this is how you get rid of, this is how you get rid of the double counting. And so the main idea is simple. Add the 2 counts and subtract the overlap. And in the example, this was, in the example we saw before, this was 33, this was 20, and the overlap was 6. And so the count is going to be 33 plus 20 minus 6, which is 47.